Photodiode means it's a kind of PN junction semiconductor diode which works with the intensity of light falling on it at the reverse bias condition. Okay, the same PN junction diode we have taken, and that is connected in a reverse bias condition. In at the junction, um, the light, sunlight or some other lights are falling on the junction. Due to the falling of irradiation of light, no more electrons are creating. Okay, if more electrons are created at the junction, means current flow will um, going on. Okay, that's the main basic principle and for photodiode. Okay, this is the picture of photodiode, and this is the symbol of photodiode. This symbol same as PN junction diode. In LED, the lights are emitted. The arrow marks are outward direction. Now the arrow marks are inward direction. So the photons, the light particles, are irradiated on the junction of the diode. Okay, this is the photodiode symbol. Then these two are the photodiodes. Photograph of photodiodes. The construction of photodiodes is these are all the PN junction is covered with the metal case. The two terminals are there. The metal case is covered with the PN junction. Then in midpoint, the top is open with some transparent glass. Okay, because this transparent glass is used to irradiate the light on the junction. Okay, that's what we are using, transparent material or glass materials. Okay, this is the construction of photodiode. Next we are going to discuss about the working principle and the VI characteristics of photodiodes. Okay, and this is the working principle diagram. As we are taking as a P type and N-type junction diode, that is photodiode, that is connected in reverse bias condition, because P type is connected to negative and N type is connected to the positive. Okay, in the depletion layer, this is the depletion layer. That is like as the depletion as like an PN junction diode. Okay, the depletion layer is formed initially before applying any potential. Okay, then we are going to introduce the incident photons are falling down on the exposed to the that this junction is exposed to the sunlight. What will happen at the time of exposure means the photons are irradiated on the junction. Okay, at this junction uh, we are connected in reverse bias condition. What will happen? The current flow is very minimum due to magnetic charge carriers. If it is connected in forward bias, means current flow is happen through the diode. Now we are connected in reverse bias condition, so there is no current flow. Yeah, minimal amount of current flow is happen. That is reverse current. That is due to minority charge carriers of um, P type and N type materials. Okay, that minority charge carriers is flowing uh, through the junction, while you are irradiating the photons on the junction, means what will happen? The photons are irradiated on the junction, that atoms, that electron hole pairs in atoms, the covalent bond is there in P type and N type materials. That covalent bond is broken. Okay, due to the irradiation of photons, light வந்து அதில் பாஸ் ஆகிறதுனால the covalent bond will broken and emits it emits the some free electrons and holes. Okay, I mean free electrons are created due to the irradiation of light. That irradiate light is broken the covalent bond, so uh, free electrons are created. So many free electrons are created means the current will flow through the junction. That current is the reverse saturation current. Okay, now we have some other terms. This is the VI cat. This is not a VI characteristics. If you are irradiating the based on the intensity of light, the current flow also increases, decreases, depend upon the intensity of the light. The intensity of light is measured by using lux meter. There is a measurement device is there. That is lux meter. That lux meter is used to measure the intensity of light. Okay. Then we are irradiating the light to the. This is the graph to explain about the light irradiation versus reverse current. This is IR. That is reverse current. That is in microampere. It's very few. Okay. Um, Now in x-axis, light intensities that is measured by the lux meter. In y-axis, a reverse current that is which is flow through the junction in reverse bias condition. Okay. Now initially you are increasing the light intensity means the current also increases due to creation of more free electrons. Okay. If you increasing the light intensity, the free electrons, more free electrons are created, so current value also increases. Okay. After reaching some point, it will not be increasing more and more light intensity, but the current will not increase. That is saturated. This is the saturation point. In that point, voltage, reverse voltage, that is a constant one. Okay. Up to this point only, the current value will increase. After reaching that saturation point, the current will not increase, even you are increasing the light intensity. Okay, this is the saturation current value, saturation point. Okay, this is the very simple explanation about creation of a free electron in this photodiodes. Okay, then we are going to calculate the reverse. Resistance, device resistance or reverse resistance. RD, that is device resistance or dark resistance, we can say. Then if you are not applying any light diode, very supply, okay, due to the reverse current. Okay, reverse bias condition, due to reverse bias condition, some few amount of current will flow when dark you are in a dark room, which means there is no application of light. Okay. இப்போ லைட் அப்ளை பண்ணாம டார்க் ரூம்ல இருக்கு அப்படின்னா அப்பவும் வந்து யூ ஆர் அப்ளையிங் ரிவர்ஸ் பயஸ் கண்டிஷன், that will current will flow, very few amount of current will flow. If you are irradiating more lights means the generation electron will generate, then current flow will happen. Okay, this is the main principle of working photodiodes. Okay, now we are going to calculate the resistance, dark resistance, that is RT. One second, somebody is approaching. Okay. Now we are going to calculate the dark resistance, that is equal to maximum reverse voltage divided by dark current. Dark current means there is no application of light, and that time we are going to measure that dark current. Okay, that is the reverse current. And then maximum reverse voltage, we are applying maximum current, maximum light, and we can calculate the maximum reverse voltage on that. Okay, that maximum reverse voltage divided by dark current, that is equal to the resistance, dark resistance can calculate. Okay, then VI characteristics of photodiode is explained here. This is the same as this diagram. This graph is same as this graph from is taken from different resources. In x-axis, illumination, E is the illumination, which means intensity of light. In y-axis, reverse current. Okay, it shows the straight line up to this point. After some point, if reached, that current will saturate as like this diagram. Okay, then IR, that is equal to, you can say that is IR, that is equal to M into, from this graph we can calculate the IR value, reverse current equation, relation between intensity of light and reverse current, that is IR, that is equal to M into E. So here M is the slope of the straight line. You can take slope value for this straight line, that is m value here. Okay, this is the relation between reverse current and the intensity. This equation shows the if intensity is increases, the reverse current also increases. Okay, this is the meaning of this equation. And the second diagram shows the VI characteristics of photodiodes. You are applying voltage potential versus current you are measuring, and this is the dark current response. If you are measuring dark current, which means there is no light on the photodiodes, that is in a dark room means, and you are applying a reverse bias condition for photodiodes, it will flow very few amount of current due to only due to the minority charge carriers. Okay, that is dark current. If you are applying a light that is about 200 lux, that is the unit of intensity of light. uh, 200 lux means that is current value is increases. Again you are increasing the intensity of light to 400 lux, that is again increases. Then 600 again increases. This response is applying here. Okay, this is the applied voltage here, this is the current value. Okay, this is the reverse bias condition of photodiodes. Okay, this is the working principle and VA characteristics of photodiodes. Then main applications of this photodiode is mainly used in alarm circuit using photodiodes. First one, this diagram shows the alarm circuit. We are all experienced in this alarm circuit in a railway station. Some are security purpose we are using. Okay, in this railway station, mostly railway station, this instrument is available to measure the count number of uh, persons crossed across the junction, or alarm circuits. Alarm circuit means somebody, this is the alarm light source, here is the light is there, here is the photodiode is there. Okay, okay, here a light source is fixed in one end, another side photodiode is fixed. Okay, if you are applying a light to the photodiode, what will happen? The electrons are generated at the junction and the current will flow. Okay, if there is if a person is crossing this way means, the current, if a person is standing here in between the photodiode and light source means, the light is blocked, okay, by the person. So the current will not I mean that light will not reach the photodiode. So here its resistance will change. Okay, therefore if a dark current is showing, so we can count the person is in between. There is an object, not a person, there is an object in between the light source and photodiode. We can uh, that alarm, this photodiode is connected with the alarm circuit. There is a person, that is the alarm will switch on, and with the sounds, and the alarm is working, and some person will go to the attention on that side. Okay, the alarm circuit using photodiodes. Okay, ரயில்வே ஸ்டேஷன்ஸ்லாம் பார்த்தீங்கன்னா இந்த மாதிரி இது வச்சுருப்பாங்க. தட் இஸ் ஃபார் dual purpose, alarm purpose, and counter circuits. இதே வந்து counter circuits கூட we can connect photodiode. That is counter circuit. அப்படின்னா நம்ம என்னன்னா, நம்பர் ஆஃப் பர்சன்ஸ், எத்தனை பேர் வந்து இதில் கிராஸ் பண்ணியிருக்காங்க அப்படிங்கிற டீட்டெயில்ஸ் வந்து நமக்கு வந்து இதில் கிடைக்கும். ஏன்னா if a person is crossing this line means, what will happen? The light is blocked by the person. Here dark current is circulating. Okay, then if a person crossed, then light is irradiated on the photodiode, the current more electrons are generated. So one count is there, one count is added to the counter. Okay, that counter circuit is based working in different areas. It's like, I will show another picture to you. And this is the, in many industries they are using counting. The number of products are going through the conveyor belt means we have to count the number of products we have produced. Okay, that is here light source is there, here photodiode is there. If there is no products or objects in between the light source and photodiodes, here light is passing through the falling on the photodiode. Okay, there's no problem. If a object is crossing the photodiode through the conveyor belt means the count is added to the counter. Okay, here 3609 some counting is there. So if this object is crossing to the photodiode, what will happen? 3610 will count. One count is added. Okay, this is used as a counter circuits also. Okay, this photodiode is connected to the counter circuit. The counter is counting based on the output of the photodiodes. Okay, this is the main two applications of photodiode. Then another application, fire and smoke detectors. If a light is glowing means here dark current is circulating. If a light is glowing, what will happen? Fire is glowing. What will happen? The light is irradiated on the photodiode. Automatically, that circuit is connected to the fire alarm. That alarm will rise. Okay, then smoke detector also. If fire accident, during the fire accident smoke is built, and then light is blocked by the smoke, dark smoke, so that's also sensed by the photodiodes. That's the another purpose. And then many medical applications are used by using photodiodes. In many medical instruments we are using using the photodiodes according to based on this principle, light and a dark current principle we are using in many medical instruments, not only in medical treatments. In many medical instruments we are using these photodiodes. Okay. Okay, thank you. This is all about today's session, photodiodes. Okay, now we can ask any questions regarding this photodiodes. If you have any doubt, you can ask now.